Good morning, sir.
Good morning, Ria.
I have something to discuss with you.
Yes, please, what is the matter?
I had seen a poster yesterday.
A poster? What is it about?
Sir, here is the poster.
Let me see it, Ria.
Sir, I would like to know more about the topic electron spin. Could you please explain?
I am really glad that you are interested in this area. Let's begin. Ria, firstly, I will explain about the discovery of electron spin that happened many years and years ago. In 1922, the German physicists Otto Stern and Walter Gerlach conducted an experiment to test the Bohr-Sommerfeld model of atom. This is known as Stern-Gerlach experiment. In this experiment, silver atoms were sent through a spatially varying magnetic field, which deflected them before they struck a detector screen such as a glass slide. The particles with non-zero magnetic moment are deflected due to the magnetic field gradient from a straight path. The screen reveals the discrete point of accumulation owing to their quantized spin. This experiment proved that electron has intrinsic angular momentum, which is independent of orbital angular momentum. This was in accordance with idea of electron spin, which was proposed by Ulenberg and Goldsmith in 1925. They proposed the idea that each electron spins with an angular momentum of 1/2 Planck constant and carries a magnetic moment of 1 Bohr magneton. However, the idea was criticized by Pauli because the electrons would be moving faster than the speed of light for it to rotate quickly enough to explain their findings. I think you get an idea about the discovery of electron spin. Now, I'm going to explain about the concept of electron spin. Spin is one of two types of angular momentum in quantum mechanics, the other being orbital angular momentum. Experimental evidences like hydrogen fine structure and Stern-Gerlach experiment suggest that an electron has an intrinsic angular momentum independent of its orbital angular momentum. Now I will explain about spin angular momentum and spin quantum number. Spin angular momentum is an intrinsic form of angular momentum carried by elementary particles, composite particles, and atomic nuclei. Spin quantum number is a quantum number that parameterizes the intrinsic angular momentum of a given particle. It is the fourth of the set of quantum number which completely describes the quantum states of an electron. Two possible states of electron spin is spin up and spin down. This allows two electrons for each set of spatial quantum numbers. Paul-Adrien Maurice Dirac, an English theoretical physicist, provided a theoretical foundation for the concept of spin. He developed a wave equation for the electrons that is consistent with special relativity. It marked the beginning of the quantum field theory. This explained the result of the Stern-Gerlach experiment, and we can see that Dirac gave a theoretical proof for intrinsic angular momentum. Now, I will explain something about an important quantum mechanical principle, that is Pauli exclusion principle. Wolfgang Pauli formulated the law stating that no two electrons can have the same set of quantum numbers. This was formulated by Pauli in 1925 for electrons and later extended to all fermions with his spin statics theorem of 1940. Spin statics theorem relates the intrinsic spin of a particle to the particle statics it obeys. In 1927, German physicist Friedrich Hahn proposed Hund's rule. The rule says that if two or more orbitals of equal energies are available, electrons will occupy them singly before filling them in pairs. Ria, I think you have got some ideas about spin.
Yes, sir. Now I've got some ideas about spin. That is, spin is purely a quantum mechanical operator. There is no classical mechanical precedence for spin. The concept of spin comes from concepts proposed by Uhlenbeck, Gaudsmith, etc. Thank you, sir.